In a previous presentation, we got some data from the Weather Underground site. My example was from Philadelphia from July of 2020. And from that, we made a line chart. In this presentation, we are going to use the same data to obtain some basic statistical quantities, average, standard deviation, and so on. I'm going to put the statistical quantities under the data. And so I want a nice separator between the data and the statistical quantities. So I highlight some cells in the last row, and then go make sure I'm on the Home tab of the menu, and then use the Borders drop-down, and I'm going to choose Thick Bottom Border. Until almost the end of this presentation, I'm going to deal with the high temperatures as they varied from day to day. So if I talk about an average temperature, it'll be the average high temperature from day to day within the month of July. Our first statistical measures are going to be ones of centrality. How are we going to get a typical or middle or average temperature, and what do we, which temperature occurred most frequently? And the reason for different measures of centrality is because they may end up to be different and tell us different things about the distribution. They are affected, for instance, by whether there are outliers. So we will be asking the question, were there outlier temperatures in July? Our first measure of centrality will be the mean. Add up all the temperatures and divide by the number of temperatures. I've made a place for it. I have a label in A34 and B34. I start to do the calculation. Now I could use Excel to perform the sum and then do the division by myself, but Excel has a built-in average function, and so I will use that. So start with an equal to say that we're going to do a calculation, then the word average spelled out, open parenthesis, and then the range of data. The data ranges from B3 to B33, and a colon between them. Our next measure of centrality is the median. If we took all of our temperatures and sorted them, put them in order from lowest to highest, the median would be the middle value. So there were 31 days in July, and so it would be the 16th value. If I were doing a month that had 30 days, then there is no explicit middle, and then I would average the 15th and the 16th value to come up with the median. In the formula, note that it is B3 colon B33, that the last data point is in B33. It'll be a common mistake to want to sort of extend the range and include the average and put it to B34. But that was one of the reasons for putting the thick line there. You want to make sure that you're doing the median of the data and not including any of your other statistical quantities in the range. Our third measure of centrality is the mode. The mode will give us the temperature that occurred most often or most frequently. So prepare the cell, in this case down in B36. And this time I'm going to use the insert function approach. So click on that sort of green FX next to the formula bar. It brings up a dialog box for inserting a function. I need to find that function. I've used the category to set that to statistical to limit the search, and then scrolled down and found a mode formula, mode.sngl, and then I click OK. I get a second dialog box to help me with the function's arguments, the data it needs to do its job. So next to number, I will enter the data. So I can either type the range B3 colon B33, or I can go out to the spreadsheet and drag from B3 to B33, and then click OK. Next, we will consider measures of the spread of our distribution of data, and our first one will be the standard deviation. A deviation is the difference between a data value and the average within the distribution. But the deviations can be both positive and negative, above and below average. And so an average deviation would just give 0. The standard deviation deals with this issue and gives us a more meaningful concept of sort of average spread. So to have Excel calculate the standard deviation, I've made a place for it down in cell B37. And then in the formula bar, I've started to enter the formula equals stdev.s. And then I gave the data range B3 colon B33. Excel provides a variety of standard deviation formulas, and the different versions deal with various questions that come up when dealing with statistics of data. One will be, is this the whole set of data, or is this a sample of the data? So the S in the standard deviation.s, that .s stands for a sample. Another question asked in these formulas is, what happens if there's a missing piece of data? How should that be handled? Just to prove that these standard deviation formulas are somewhat different, I have here in cell B38 given the formula using the stdev.p version of the formula, and you see that the number turns out to be slightly different. Now, as the number of data points goes up, the difference between the sampled standard deviation and the population standard deviation gets smaller and smaller. But with 31 points, you can see some difference. If you were to click on fx and then use the insert function dialog box, you will see that it provides a description of the function, and it also provides a link to even more help on the function provided you're connected to the internet. Excel provides a function that will provide the minimum from a range of values. So the formula is equal min open parenthesis and then the range of numbers B3 colon B33 close parenthesis enter. If the standard deviation was giving us a typical or average spread on our data, then the range, which is going to be the difference between the minimum and the maximum, is going to tell us about the extremes of the spread. In the cell A40, I typed the text second smallest, which did not quite fit in the cell. So I handled that in the following way. I right-clicked in the cell, and from the context-sensitive menu chose Format Cells. And then in the dialog box under Rows, I went to the Alignment tab and checked off the Wrap Text checkbox. We can see in cell A40 the result of the wrapping, that second and smallest are on different lines. And now we go over to B40 and we're entering the formula equals the function name small, open parenthesis, then the data range, B3 colon B33, and then a second argument, in this case a 2. The second argument determines which of the smallest values you want. 2 will be the second smallest, 3 will be the third smallest, and so on. Notice that the data result is 83, and the minimum, the first smallest, was in the 70s. So this is a substantial difference between the second smallest and the first smallest. And so again, we had that question we were asking along the way, does this data have an outlier? And this is some indication that perhaps it does. Now we turn our attention to the other end of the range and calculate the maximum. So there's an Excel provided function called max, and then we enter the data range, B3 colon B33. Just as we were able to find the second smallest, we can find the second largest. So we're using the function large. So in cell B42, we are entering the formula equal the function large, open parenthesis, B3 colon B33, comma 2, close parenthesis, enter. The second argument 2 is what is getting us the second largest. If it were a 3, it would get us the third largest, and so on. Note that when we are dealing with these extreme ends of the distribution, whether it be the very high end with the max and the large, and the very low end with the min and the small, we are in the portion of the distribution known as its tail. Recall that when we were considering measures of centrality, we had the concept of median. So we sorted the data, put it in order, and we found something that was sort of halfway or 50% of the way through the list. The concept of quartile extends that idea, and the first quartile is an indication of the point that is 25% of the way through the data, and the third quartile is 75% of the way through the data. And then this, together they provide a measure of spread in that 50% of the data lies between the first and third quartile. Seen here, we are entering in cell B43 Excel's formula for the quartile. Equal quartile.inc, open parenthesis, the range B3 colon B33, comma, and the second argument here, a 1, is indicating that it's the first quartile. Again, the first quartile is if we were to sort the data to put it in order from lowest to highest, the first quartile marks a point that is sort of 25% along the way. There's some subtleties in the definition of quartile, and that's why Excel supports a quartile.inc inclusive and a quartile.exc exclusive. In the first quartile, the exclusive version, the .exe, will be less than the INC version. We can get the third quartile as shown in cell B44 by using the same quartile.inc function, the same range, B3 colon B33, but this time the second argument is a 3, standing for the third quartile. Again, if the data were put in order, sorted, and in increasing order, the third quartile marks the 75% position. And for the third quartile, the EXC, the exclusive version, is greater than the inclusive version. The quartile.inc function supports more than just the first and third quartiles. The second argument can be also 0, 2, and 4, 0 giving the minimum, 2 recovering the median, and 4 recovering the maximum. In the quartile.exe version, the exclusive version, the 0 and the 4 are undefined, whereas the 2 again recovers the median. There's a related function called the percentile function. So you can recover the first quartile using the percentile function, equal percentile.inc, the range B3 colon B33, and to get the first quartile, a 0.25, representing the 25% that the quartile is. To recover the median, you can use percentile with a 0.5 for 50%, and for the third quartile, a 0.75. But the percentile function allows you to go to other things, such as 0.9. This would be the 90th percentile, the mark where 10% of the data would be above and 90% below. And the percentile function has an EXC version, an exclusive version, the same way as does the quartile. These quartiles, including the 0 at the minimum, the second the median, the fourth the maximum, and the first and third quartiles, all go into the making what's called the Box and Whiskers plot, a visualization of the data, its centrality, its spread, and so on. Excel provides a Box and Whiskers chart. Highlight the data, go to Insert on the menu, go over to the Chart region, find the Statistical Charts, and choose Box and Whiskers. This is also the location one would go to make a histogram, which we will talk about in another presentation. Again, the Box and Whiskers provides us a visualization of our basic statistic quantities derived from our distribution. So we see our measures of centrality, our mean and our median. The mean is represented by that X sort of in the middle of the blue region. The median is represented by the horizontal line in the middle of the blue region. The first and third quartiles down at the bottom are represented by the width of the blue area. So the top of the blue area is the third quartile, the bottom is the first quartile. Our maximum is the thin line at the top. Our minimum is represented by a dot that is outside of the Box and Whiskers because the 77 happens to be an outlier. We haven't defined that completely yet. We will do that in a subsequent presentation, but it is indeed an outlier. And therefore, it's the second smallest value, then sort of playing the more usual role of the minimum in the Box and Whiskers, being this sort of lower bound. So we have the whisker, the thin part, sort of representing the tail of the distribution going all the way to the extremes of the max and the min, or at least the smallest value that's not an outlier. And then this thicker region in the middle that represents 50% of the data between the first and third quartile. Everything we've been considering so far, all our statistical quantities, have been on the high temperature data for the month of July. Now we would like to extend these results to the average temperature and the low temperatures for those days, and we could go farther on and do wind speeds and what have you. So you'll highlight the data. Remember, each one was a formula. And then we're going to highlight the data, we're going to use the select cursor, the fact cross, and then we are going to move into the corner of the highlighted region down near the lower right hand corner of cell B44 and get the thin cross or the fill handle, and then we are ready to drag our formulas across and copy them into the other columns. You see here dragging the fill handle across 2 columns, copying the formula. Our formulas used relative addressing, no dollar signs. So let's see the result. Let's look at the formula that was in cell B34, which was equal average B3 colon B33. When that is copied horizontally over to cell C34, the formula turns into equals average of C3 colon C33. Therefore, we are now taking the average of the data in column C, which was the average temperature for all the days in July.